Okay, sounds good. Welcome everybody to March 25th, working Carpenter Working Group meeting. Um, so let's get started. First off, let's get started with the project updates. From the Carpenter team, main thing that we have going on is our path to V1. Currently we have two main laundry lists. One in the uh, one in the Kubernetes 6, as well as one in the AWS provider. If you have any major issues or conversations that you would like to talk about, please feel free to add it into those issues. I believe Jonathan will also be making an RFC soon, um, to include all the changes or to compile all the additions that are here and make them into a formalized doc. And then afterwards, we can have more conversations about that as well. I believe that should be going up in probably the next few weeks. Yeah, but there is definitely progress going to towards V1. Any questions on that? Cool. Next thing is we are also planning on working on the observability improvements. Currently, we're planning on adding health conditions to our Carpenter resources, planning on hopefully uh, removing some blocking dependencies we currently have against this, but making path towards this. And we soon will hopefully have an RFC to see what is an integral part that customers would like to have better observability on than we currently deliver. Um, yeah, if you have any comments, concerns, please feel free to add it into the issue, and then hopefully we should be making additions to that as well. Um, yeah, next thing, an update from Cappy.
Yeah, thanks, Nick. Things are going pretty well in the Cappy world. I've got a scaffolding set up now. I based a lot of it on the Quack provider, which is an okay starting place, but I'm quickly kind of getting out of those training wheels. There's two kind of questions I've been I don't want to say struggling with, but just kind of going back and forth on. One of them is kind of like looking at how currently the configurations are for the AWS and Azure implementations. It looked to me like there's heavy use of environment variables to set them up. And I just wanted to kind of confirm what the community's approach here was. Is there a preference for, using like a lot of, like I saw the flag stuff in there, but I didn't know like what is the best option? Like I saw the Helm charts using the environment variables and whatnot. Is there like a community kind of opinion on this, or I guess a direction I should follow, or any suggestions?
I have net new opinions that I've formed recently and I've never talked to anybody about. If you want to hear them.
Yeah, that sounds amazing.
I've been writing a couple of other controllers outside of this project and wrestling with this like library of, defaulting from the environment variables and then backing up to the flags. And I ended up shooting myself in the face a couple of times with some surprising things. I decided that the juice is not worth the squeeze, and you should just pick one of flags or environment variables and not both. Um, obviously Carpenter does both right now, and I don't know what do we do in our Helm chart right now, Nick? Do we do environment variables?
We have some environment variables that are respected for the Helm chart.
Yeah, so the decision I made was you already have to do a bunch of environment variables for like that's what any of your libraries expect. It's like hard to pass flags to libraries due to the flag parsing ordering problem. And environment variables are a little bit more magical, but it is like more natural to pass things like AWS region or AWS account ID to various libraries. And so I don't know, in other projects, and I don't know if I'd recommend this to like Nick or any of the other maintainers here, but I decided to just throw away all that machinery and just use environment variables.
Thanks. Yeah, I appreciate the thoughts, and I think you're right. Like, environment variables is very easy for me to throw in, especially now as I'm kind of building up the POC. So yeah, I'll just keep going that way, and I guess like if nobody complains, then it's probably not a big deal. The second question I'm kind of running into, and I don't think this is really controversial, but I'm just trying to understand how to fit it into kind of the controllers scheme that I've seen used in the AWS and Azure one. So it's looking like in cluster API, we're going to need to have two controllers, one for kind of the normal node claim stuff, processing those requests and doing the, providing the cloud provider interface back to the core Karpenter. And then the other controller will probably be the one that we'll have to have talking to our, our cluster API, management cluster, we call it, right? And that is where this is where it's going to get complicated. I think we're going to need one controller to get the nodes and pods for that information, and we're going to need another controller to talk about node claims and machine sets and like the cluster API pieces, because probably this is going to be deployed in a way on cluster API where we'll have a kind of a hub spoke configuration, where it's like we'll have a management cluster and then several copies of Karpenter running in the management cluster. The resources for the spoke clusters will also be in the management cluster. And I imagine the node claims and node pools will as well. But then the nodes and the pods will need to be read from the workload clusters, the spoke clusters. So is there, I guess, like, am I getting into a dangerous area here? Is there like a pattern I should be looking at, or any suggestions, I guess, in that direction?
So it sounds like at least the events that you'd be wanting to consume for the nodes and pods would be in a different cluster, so you wouldn't be able to have like a list watch cache on those, or okay.
Yeah, I mean, it very well could be that like the node claims and node pools exist in what we call a management cluster, but the nodes and pods exist in what we call like a compute cluster, right? So we'll have to somehow make it so that the core Karpenter controller, uses the right kube config to send the node claims, and then uses a different kube config probably to read the pods and nodes and whatnot.
Yeah, it's an interesting thing. I don't think we've actually thought about multi-tenant list watch caches, because that's really how we do it within Karpenter, is that we can just rely on the list watch caches, and then we also have our cluster state, which keeps track of like important information that we know of. The cluster state, I think in particular, is also based off of this list watch cache, and we just keep track of the important events on these resources that we care about. Yeah, I wonder if there's a way to.
Do you want the
sorry.
node claims in your management cluster? Is that the idea? And also your CAPI APIs? Or would it be possible to have the node claims in the workload cluster?
Yeah, so this is like,
I'm just thinking of like name conflicts and other stuff if you're doing multiple.
Right. Like I was talking about this with the cluster API, feature group, right? And they think that like from a user perspective, it makes more sense to have the node pools and the node claims with the machines and the machine sets and that stuff, because that's going to be done by like an operator in the management cluster or an administrator in the management cluster, whereas all the workloads are going to live in the workload cluster. And they didn't think that it made sense to have the node pools and node claims coming from the workload cluster while all the machines and everything lived in the management cluster. And so that was kind of where the discussion went with the cluster API side of things. Even though it's kind of interesting, the thought of having the node pools and node claims in the workload cluster, because that starts to break some boundaries between like the administrators and the users of the cluster, because you can see where it's going. So yeah. So like I guess this split between where the nodes and pods information comes from, the kube config for that, and then the kube config for the node pools and node claims, like I guess that's part of the core of Karpenter right now. So like, is that, yeah, how do I split that one?
You want it to be less invasive to the Karpenter project, you could run a little proxy next to your, I've built this for other systems, like run a little proxy next to your controller and just fork off whatever traffic you need and do whatever you want to it. So you could even like fake the kube config and then talk to the proxy, and the proxy has the real kube configs, and do it by path, whatever you need to do. So from the perspective of Karpenter, it just looks like one cluster. I don't know how you do like watch. I mean, watches are probably fine. It's a little bit of complexity for you to manage, but that would be like a zero code change to Karpenter approach.
Right. And then we could deploy like a specially configured kube proxy alongside of the Karpenter that we deploy. Oh, that's
Might be generally useful actually, like a kube multiplex proxy that
right. Right. I like that idea.
might even exist if you Google it.
I'm sure no one else is going to like this idea when I go back to the cluster API folks, but it's an interesting idea. Okay. I guess that gives me some stuff to research and whatnot. I appreciate the conversation here. Thanks, everybody.
Okay, cool. I guess moving down, we have no RFCs, at least for this week. Community question.
Yeah. So I'm working on trying to convince people in my company that Spot can be trusted in prod. And part of that journey is going to be just getting data to kind of like understand how frequently disrupted Spot instances are and like how much will we be theoretically like using practically across the cluster, that kind of stuff. So as part of this journey, I've been trying to like dig into the available interruption metrics, and I'm coming up with lots and lots of zeros, even though we're running like over 100 Spot instances. So I guess, does anyone know anything about these interruption metrics? Are they still work in progress? Are they supposed to be working? Yeah.
You have the interruption queue enabled, right?
Sorry, say that again.
You have the interruption queue enabled?
Interruption queue, and is that enabled by default?
We recommend it in our Helm chart. I'm not sure what your setup
It's
looks like.
it's not
though.
enabled by default, but you can install it yourself and you can use it.
All right, that's definitely one.
And I can tell you that it works pretty well.
Okay.
Like, yeah, it works pretty well. Like you get every time you, I mean, like you, I mean, look at the metrics. Like, look at, I mean, you're from Datadogs, right? So, but if you look at the metrics of your nodes terminated, and if you run it for a week, you can see every time a node is terminated from a spot that you actually see the event too beforehand.
Okay, so I'll see. Will I see that without this interruption queue enabled, or does the interruption queue enabled be?
No, you need the QR. You need to enable the like
Otherwise,
the queue. You need
Karpenter
to
just
set up the
doesn't
queue.
receive messages whatsoever.
Correct.
Okay,
Correct.
gotcha. Thank you.
Yes.
That's extremely helpful and succinct. So,
Yeah, we basically need some sort of, we use an SQS queue to consume auth events and instance stopping events. So if you don't have it, then, or if you have like native termination handler,
yeah,
spot
and I
termination
just
handler.
assume that would be running by default for some reason, but that makes sense. Yeah.
One thing to note is if you have that enabled, it's still possible, I guess, for this interruption deleted messages to not occur if you have like fast expiration or fast consolidation. So like it actually doesn't live long enough for the spot instance to be interrupted.
Right. Yeah. I assume that an actual interruption has to occur and reach Karpenter before any of that would happen. And if something kills it before, then yeah, obviously you're not going to see a spot interruption. So.
Check out the fault interruption or was it fault
injection service.
Yeah, this is like the gold standard for how to test this. Like,
yep.
Ideally, you in your pre-prod want to test that interruptions are being handled, and so you can actually just like fake them yourself and observe your resilience. So we see customers just like being super aggressive with that in lower environments, and then they get the confidence in the upper environments.
Cool. Thank you.
Yeah, one experience that we've had is having our stage clusters in some spots 100%. Again, has that interruption on there. I've got weighted node pools, so the spot's number one at the moment, and then it waterfalls down if spot capacity ever gets hit to an on-demand. That way we know even if all the spot instances get reaped, we've got the few minutes to then scale up and it goes into the on-demand pool as required. Having it inside of production, one thing to be aware is, especially with AWS, there's no guarantee with spot instances, and at any point they could call in all the spot instances because another customer has suddenly requested 10,000 on-demand instances. So making sure you've got that kind of balance between and having that waterfall gives that security. But inside of production, we allow teams to opt in to Spot through affinities or soft affinities mainly, just for the cost savings and utilizations, but we never mandate production to be Spot. And that seems to be working for us quite well. Over the past week, our Spot instances, I've had 3,000 consolidations for Karpenter and 60 interruptions of Spot instances. So inside of a spot only cluster, the consolidation's a lot more aggressive with our default configuration than what we get from interruptions from AWS.
That's what I've seen as well in practice. And yeah, the main like spooky like scenario that we're super concerned about is if we're running like pods that are spread across 3 AZs, and then one of the AZs just explodes in AWS for whatever reason, then everyone also running in that AZ outside of our company also going into pull instances from the other 2 remaining AZs and yoinking all the spot availability we have in those other 2 AZs, which would
Okay.
potential real outages. So
And
Yeah,
you're using the capacity spread, right? That feature, like there's an example in the docs. Have you looked at that?
No, this is a follow-up question that is good to answer. So it's called
Okay.
capacity spread.
So we use that, for example, like it's very useful because it basically guarantees that, for example, if you say, oh yeah, I have 3 AZs and whatever, you can set it up to say, oh, I only want to run 2/3 of my fleet on spot, right? So even if all spot goes away at the same time, you have some capacity left that is on demand and that doesn't go away.
Oh, are you talking about just using topology spread for this?
Yes, I mean, in the docs, you basically use a topology spread constraint, right?
Yeah.
It's called capacity, yeah. But
Yeah.
basically, you can guarantee, like the way how smart Karpenter is, right? It only spins up specific. It does a ratio, right? You can configure a ratio, and basically you would have a specific ratio per AZ if you wanted to, right?
Okay.
So even if all spot goes away, you still have capacity in each AZ, and hopefully can serve traffic for the next 2 minutes until new instances come up.
Okay. Yeah, I might ping for a link to the docs on that in the Karpenter channel or something after this, but oh wait,
Put it
yeah,
in the Zoom chat.
Thank you.
Yeah.
Okay, this is perfect. Awesome. I will
Yeah, it's also,
do this.
yeah, it's worth noting on this one that this is kind of like a hack that you can enforce things to be spread across your node pools.
real
But it's not
question.
necessarily, there's still like there's a cap that is that someone has requested, which I also need to find,
Yep.
of spreading your pods or spreading your nodes across some common label across the whole cluster.
Yep.
And we currently don't do that within Karpenter, as like this node pool setup has suggested, is that we don't actually spread nodes or pods across AZs inherently without you telling us to.
Right. So would this work within the same node pool, or is that going to be like is there any way to say that I want to maintain that like only up to 50% of the node pool is spot, for example, of a particular node pool, but that also does on demand and spot?
I don't think you can do that today of having like a per node pool like spread.
So we would have to be not mixing, and you'd have to, yeah, okay. But you could have, can you have 2 node pools that aren't segregated and where Karpenter will choose either one? I guess you could have a preferred spot node pool and then fall back to an on-demand node pool.
I think that's pretty common
Okay.
as well.
Okay. I think that answers my questions. Appreciate it.
Cool. Next issue. Yes, migrating from Knative Blogger to a controller runtime.
Hi, this is actually not a question, but just wanted to give a heads up that this logger, which was based on the Knative, is being replaced by the controller runtime. I think there are no breaking changes or whatsoever. It's just a logging being changed internally in the code. But I think Jonathan asked me just to give a heads up to the community about this change. Yep.
Okay, sounds good. Thank you for that. Next thing.
Strikes me, like there's maybe a process improvement we could make here. Like I think we're deciding that the log formatting and content is not considered an API, and that we can change it without breaking changes. Is that, or unless you're telling me that the logging content is literally identical to Knative, which I'd be super surprised by.
Yeah, there were actually some questions which we kind of agreed to fix as a follow-up. So there are some logging that people kind of think that they're not supposed to be considered as a tracing logging, or some are considered error, but some people think that it's not an error, but just a debugging. So in the controller runtime, what I did with these changes, basically I used two different levels of the logging. One is the info, the other one is the debug. And whatever was previously with the key native using the debug, I'm using the similar in the controller runtime, and whatever was in the info, but with different levels, it's also being converted into the info. But then I don't remember the name of the person because I'm new to this community, but somebody asked me to analyze the code base and see if we're using debugging messages correctly, or if it's info being used correctly, or if the error is being used correctly. Because sometimes some people were complaining that there's too much of logging, like the debug info, the debug messages being printed out, which doesn't necessarily need to be printed for every user. So yeah, I think there's going to be some follow-up to clarify how messages should be interpreted.
Back to my, I guess I was trying to make a slightly different point, which was that, like, I think some of the like the literal log strings that are being printed are going to be different after this change. And I think that's okay. I think that what we're essentially saying is the contents of logs are not an API, and they may change at any time. So if a customer is parsing them and has logic, they shouldn't expect backwards compatibility on the log.
Yeah.
And so
Sure.
I guess the call out I was trying to make is, and Nick, maybe you could take this up, or you know the right place for where this should go in the docs, but we should probably in our upgrade guide or something just be really clear about the policy. My gut, and maybe we need to just like be super explicit about this by V1. But my gut is like metrics should be considered API, but logs shouldn't. And of course, our API is API. And then maybe like environment variables and such as like the install parameters is maybe not considered API. Like we don't provide a guarantee to that. But anyways, we should sort that out before V1 and just have a clear story. But it just came up for logging, and I think it's this may be a good example to point to when we write that doc.
Yeah, totally. I think you're spot on with how we've kind of been treating breaking changes or not right now, which is you can't rely on logging to like specific structured values or things like that to be API, but we do that for our API, we do that for metrics, we do that for names of metrics or the labels of metrics. We could also talk about whether events can be relied on as well. But I think that's definitely something we need to figure out for breaking changes going into V1.
I guess moving on. I'm slicing GPUs. I guess does anybody want to add on to that, to this one?
Yeah, hi, I'm the one
Yeah.
who added this.
Yeah.
I'm kind of new to the project and carpentry in general, but mainly this is the idea of having a custom resources on nodes or transforming the resources on nodes, where we could, Karpenter only sees that a node has one GPU, but we can split that GPU into any number of GPUs through time slicing or MIG devices or whatever. I realize that like DRA is on the horizon at some point, but I'm not entirely sure of the actual like timelines in regards to that. There's a second open issue of, I think it's 751, that talks about just custom resources in general, things like huge pages and whatnot, fuse devices. basically I had an idea of an approach you could take to this, but I was just wondering like if there's any advice for getting started on like an RFC for this. Like, is there when it comes to adding like new CRDs and stuff like that, is that something the community is open to?
So, specifically on the whether we should have a CRD or not, I think a CRD is kind of like a big API surface that we'd want to add in and would be a lot of maintenance. I think the funny thing is I think the last meeting or the meeting before that, I think we'd also talked about custom resources. And I think Matt and I and some others discussed, maybe I'm wrong about remembering this, but I think we discussed about opening another thread to discuss about custom resources and what we want to do on this, because this is a pretty long-standing issue. And yeah, we have an outdated doc on how to do an RFC, but I think in terms of collaboration, some people like to do like a Google Doc and iterate on that quickly, and then once you have a little bit more, then you put it into an RFC into the issue, or sorry, into the repo. I think if you're willing to, have a little bit more discussions about this, I think it'd be worth having some sort of open thread in like the Kubernetes Carpenter Dev Slack channel, if you're not in that one already. Because I think there's been a lot of people who've asked for this before, and I think there's plenty of capable people who are willing to work on this and start talking about it and figure out what the best solution is for this.
My number one advice would be just like get consensus with the maintainers quickly, like understand the problem space, have an opinion yourself, and then like try to just chat on Slack or in public and just like get consensus quickly, and then we can produce like a more formal doc that we take to vet against like real customer use cases or whatever. But ultimately,
okay.
folks like Nick and Jonathan and myself, like there's a lot of prior art here and a lot of discussion and a lot of history. I'd be happy to chat if you want to ping me on Slack, just like some of the history behind this. I really want us to make progress on it, but it's thorny for sure.
Yeah, I am in the Slack, so I'm happy to jump in there. I think I did jump in there a little while ago just to basically say hi, like I'm interested in solving this problem. But I have seen some of the prior art. Like I know there was a IRC, I think from Jonathan, about like an instance type CRD where you could like kind of alter the instance type. And I had a somewhat similar idea where it's effectively like a node pool transformer where you could target a node pool and specific instances in that node pool and then transform those at the evaluation stage to add those custom. Anyway, we don't have to get into the whole thing, but yeah.
And you have the use case yourself, right?
Yeah, absolutely. So the company I work for has recently started a migration to Kubernetes, and we have a large amount of GPU workloads. And like our solution right now is effectively just have like a pod that kind of does nothing, that anti-affinities to its existing pods, so that a node just kind of sits there pre-ready with the resources available to schedule stuff with custom resources, so that Karpenter doesn't have to be in the loop.
Yeah, that sucks. Let's do better. So
Yeah,
I'm super excited you have
we,
this case, just because working
I
backwards.
also
Oh, go ahead.
I also called in just because of this issue, and here in Intel we're also keen to contribute if this is if acceptable. And the use case is pretty similar, so we've also experimented with this sort of extra pods and whatnots. Those usually they don't work always as one would expect. There are always some kind of a drawbacks with those kind of approaches. So would really want to have a proper solution here.
The fatal flaw last time is that we had a theoretical use case and not a real use case. And so like I'm glad both of you have the real use case. It's like it's just always going to be easier. I mean, I think in general for the project we push back pretty hard unless we have like someone who's actually going to use it immediately, and this is the only thing that they can do, just because otherwise you end up building a bunch of theoretical things and the project kind of gets crushed under its own weight. So I think I'm excited that we might have a better chance of success this time around, given that you guys have the concrete use case and are excited to drive it with us.
I mean, for people who do have actual use cases and are blocked by issues similar to this, where's the best place for us to surface that kind of like user story so then we can work and ensure that the solution that's being designed is compatible with all of our different individual use cases for this?
Well, you say, sorry, you said you have a concrete use case or you have a theoretical use case?
Oh no, this we've Appalachia, we've got exactly the same, not with the GPU time splitting, but with KVMs, and so we've got requirements on the KVM requests and limits, which Karpenter can't handle. My workaround right now is using an open provisioner, so it commissions those relative nodes, and therefore those pods get scheduled, and then when the open provisioner runs out of capacity, Karpenter then kicks in and creates more relevant nodes. It's not pretty because it's open provisioning the cluster, but it does the job for us to continue to roll out Karpenter to all of our clusters. But it is something where this mega issue, and from what sounds like related to the topic that was just discussed, would be the solution. And the one thing I'm seeing is that there are multiple ways, and you can see in this particular PR, we've got multiple potential PRs which could resolve this issue. And it's just making sure that we've got, as you mentioned, the maintainers are happy with the direction that this is going, because it sounds like it's becoming more of a common issue and likely one that would need to be a 1 point inside of 1.0 for it to really become mainstream based on what I'm hearing on the call.
Yeah, I'd recommend just collating. We typically use mega issues for this. So this one we have highlighted here. Just we should probably link like the RFC that we did to this and just kind of, I guess it is technically linked. Yeah, but we tend to like track these like major initiatives in the project in mega issues and then link all the stuff to that.
Okay, might start some threads as well, and or a thread in the Karpenter dev, because see if there's anything we can do as a workaround until such time these issues get developed, tested, and released.
Yeah, I also just put a message in the Karpenter dev thread. I'm gonna make a Google Doc so we can start aggregating all these use cases and actually start talking about it in a Google Doc so that someone doesn't come say hi and then we forget about their message 2 months later.
That's great. Thanks very much, everyone, for hearing me out.
Okay, sounds good. Okay. Is there anybody else that has any other questions? Any other comments that you would like to share? If not, then we can call it good for today. Okay, sounds good. Yes, I guess that will conclude our meeting for today. Thanks everyone for joining.
Thanks, everyone.
Thanks, everyone.
Okay.